Hello viewers, welcome to Physics with Sanmitra. I am Sanmitra Bhomik and today we are going to start circular motion. This video will explain about the basics of circular motion. What is circular motion? What is angular velocity? What is angle? What is speed? Angular speed? What is angular acceleration? Types of acceleration, etc. And you have to watch this video very carefully because this video will explain some concepts which we will be using later in the next videos. So let's begin. First of all, before studying circular motion, let's say what is a circular path. Say this is, I am drawing a circular path. Okay, this is a circular path. Now what will I do? Let me draw properly. Here, as the particle is moving on this path, it is subtending an angle at the center, or say any point. It is subtending an angle at the center. See, this is an angle. Now I don't think I need to tell you what is an angle. This thing you have already learned in the very first chapter, that is units and dimension. So this is angle, that is say theta. I am representing angle by theta. Now since it is moving like this, it is subtending an angle. If it is moving in a complete circle, what will be this angle? This will be a complete, it will move like this. This will be 360 degree, or that is, I can say 2 pi. 360 degree, or this is 2 pi radian. 360 degree in degrees and 2 pi in radian. We will be using radian mostly. Now this angle which it is subtending, that actually depends on the point from where I am considering. Suppose a particle or anything that is moving in a circular path is a part of a circle. Now what it is subtending an angle, say this is 30 degree with the center in the center. Now what it is doing? Now let me take another angle like this. This will be more than 30 degree, right? Suppose I am taking it is at a greater distance, then this will be something less than 30 degree. Say this is 40 degree and say this is 20 degree. So it depends on the distance also, the point also at which we are finding the angle. Okay, now I think you are getting a little bit idea what is angular displacement. See, it is moving from here to here. With respect to this point, it is moving an angular displacement theta. It is moving from this point to this point through this path. With respect to this point, it is moving an angular displacement of 30 degree, or pi by 6 radian. So this is angular displacement. What is angular velocity? Angular velocity will be the rate of change of this angular displacement. That means how fast I am moving and how fast this angle is changing. What is angular acceleration? Okay, we'll come to know. So you have the basic idea now what is angular displacement. Now angular displacement is not only limited to circular motion or anything like that. Wherever it is subtending an angle, and that angular displacement if we can measure, then that is the angular displacement. See, one complete circular motion has 2 pi angular displacement. Angular displacement is not limited to circular motion only. See, there is a car and this car is moving on a straight line. Now this car, initially it was like this from this point P, that is the point of reference, and since it is moving like this, it is moving a linear displacement of say d, capital D, but it is moving an angular displacement of theta radian with respect to this point P. With respect to some other point, say here, it is moving some other angle, say phi, say this is q. So this is how we define angular displacement. I hope it is clear. Now, what is angular velocity? Angular velocity is rate of change of angular displacement. See, in this circle, suppose this particle is moving here like this. Now, along the circle. Now, it may not be along the circle, it may be along any path. Now, the thing is that when this particle, it is moving along the circle, along the circumference of the circle. Now, how fast this particle is moving, that will determine how fast this angle is changing. Now, did you get me? This particle is starting from here Now the angle is 90 degree. Now the angle is 90 degree with the, suppose here I am here now at this point. Now the angle is 90 degree. Now how fast this angle became 90 degree? So from 90 degree it is becoming 135 degree. So how fast this angle is becoming from 90 to 135, that change I am trying to measure with respect to time. So this is similar to normal velocity, linear velocity only. See, this displacement, I can say that this displacement is S along the path curve. This is R. Then S is equal to theta R, where theta is the angle in radian. We already know this from geometry. Now I am differentiating it. This is scalar, okay? So I am differentiating it now. This ds by d theta, from here differentiating, that will become, theta will become d theta by dt into r plus theta into dr by dt. Now in case of circle, this dr by dt is constant, but in case of other curvilinear motion, say the circle radius is increasing like this, or say it is moving somewhere like this, and the radius of curvature, I will come to that point later, what is radius of curvature, that is increasing or decreasing. So in those cases, I will be telling you that in those cases this dr by dt won't be 0, but in this case, since this is circular motion, this is moving in a perfect circle, so I can say this part is 0 because it is moving in circle. So I can say v is equal to omega r. See, ds dt, that I will say v because it is moving. That is the speed, linear speed, that is angular speed into r. R is the radius. This is angular speed because I am taking the distance and the angle covered. But now I will be showing you in vector form what is angular velocity. In vector form, it is defined as v vector is equal to omega vector cross r vector, where r vector is the position vector of the particle. So this is the particle, this is my r vector, this is my, I will show the sign, this is my r vector, this is the particle p, point p. Now it is moving with a velocity v is along in the plane, v is in the plane of the circle. Now what is omega cross r? See here, omega cross r, omega is in the upward direction, r is in the, say, x direction, say k cross I cap is equal to j cap. So this v is in the plus y direction, so v vector is equal to omega cross r, all in vectors. So this is very important in vector form. And see, omega, one more thing I have to notice here, that is this omega vector, this is perpendicular to the plane of r vector and v vector. At least r vector, it is perpendicular to the plane of r vector. Okay, this much I think is clear. Now our question is, I have been given that theta t, that is the angular displacement with respect to time, as a function of time, that is 3t square plus 4t radian. Find the angular velocity. This is a very simple question. I will be finding the d theta by dt, that is angular velocity or angular speed, whatever you can say, because I am not mentioning the direction, it will be angular speed. What is d theta by dt? 3t square, that will be 60. 40, that is 4. If you are finding difficulty in relating differentiation and integration, if you are a new class 11 student, then please go through our video for basic calculus for physics, that is in our mathematics and vectors playlist. Okay, 3t plus 2 radian per second. See here. Now you will be asked to find omega at t is equal to 1. That you will get omega 1. So t6 plus 4, that is 10 radian per second. Okay. Now let's look at this problem. Find the angular velocity of the body with respect to point shown when x is equal to 4 meter. See, this object is actually moving along this line, and there is a point shown around the point. See, this is the point. The they have been showing here. With respect to this point, find the angular velocity of this object which is moving like this when x is equal to 4 meter. See, when the object is here and this distance is 3 meter, and definitely this is perpendicular also. This should be mentioned. Now, since it is moving with a speed of 10 meter per second, now let us find the angular velocity of, see, this angle is theta. I can say this angle is theta. Now see, as initially it was like this, now as it is moving this side, it is becoming like this. So this angle is increasing. So as the velocity increases, what is the rate of change of the angle? What is the rate that with which the angle is increasing? Now let's see, if this is 3 meter, and if this is 4 meter, what will be this? This will be 5 meter, 3 root over 3 square plus 4 square, that is 5. And what is this angle? This angle is 53 degree. Now let's see one thing. What is angular velocity? How to find the angular velocity? For finding the angular velocity, we will resolve this into two components. So this is 53 degree, and so this will also be 53 degree. So you can say this is 37 degree. So I can write here V cos 37, V sin 37 degree. Now just tell me one thing here. This V cos 37 degree, just understand it conceptually. Just V cos 37 degree, this component, this will move in line with this one. This will not contribute to the change of angle. I am repeating once again. Suppose I have a point P here, this point P, and I am moving a particle just like this. Will it contribute in any change in angle? No. It is just moving directly in line with the point. But if I am having a say velocity which is always perpendicular to this, so definitely it will always try to change the angle like this, again perpendicular, like just like circular motion. The velocity is always perpendicular to the displacement. Therefore it will be just like circular motion. Therefore I can say that this component will have no effect in angular velocity. It will have no effect in impact on the angular velocity. Only this component will have. So I can say this is V perpendicular. Therefore I can write, see, I have already resolved it into components. See, when x is equal to 4 meter, the theta is 53 degree, this is 53, this is 37. Omega is equal to V perpendicular into R. So R is the distance and V perpendicular is this one. Only this one is contributing to this. Now see, this in circular motion what happens? This is most of the times, see this, what happens, this radius is constant in circular motion. In circular motion this radius is constant. But here what is happening? This radius is increasing, and this radius is increasing, and this theta is also changing. This V is constant. Since that is why this V sin 37 will also change. Okay, so this is, I am just finding at one instant. It is not that this is the angular velocity. Now this V perpendicular is V sin 37 degree divided by this length is 5. So if it is V 37 degree and it is 5, then what is the answer? The answer I can say V sin 37 degree. V is 10, sin 37 degree is 3 by 5 divided by 5. So in 5 the 2, that is 1.2 radian per second. This is my angular velocity. Now let's see this question. Find the angular speed of the projectile at the highest point of the trajectory with respect to the point of projection. See, there is a projectile which is being launched with a velocity u and at an angle alpha with the horizontal. This is the point of projection. Now let's see. it will follow like this path. At the highest point of projection, the velocity, it will have some velocity. And what is the angular velocity with respect to the point of projection? This is the point of projection, so this is the angle it is subtending. See, the angle is changing definitely. Initially the angle was like this something, then it is changing. So what is the angular velocity, angular speed it is asked of the projectile at the highest point of the trajectory with respect to the point of projection. Now see this part. Let me draw the projectile trajectory. This is my u. If I resolve u into two components, horizontal and vertical, this will be u cos alpha and this will be u sin alpha. Now at the highest point, what will be the velocity? Velocity will be u cos alpha, since there is no vertical component. I have already covered projectile motion, so if you are facing problem in this question about the basics of projectile, you can see my playlist. Now this, what you can do here is that this is capital H and this is range by 2, half range. Now what is the length of this? What is the length of this? This will be, I can say, let me write it as, say, small r. Small r will be half range square plus half range square, sorry, h square, the maximum height square, plus half range square. Now we are asked to find the change in the angular velocity. See, as I already told you, if I resolve this into two components, one is along the line, another one is perpendicular to the line. The along the line component, that is u cos alpha cos theta, and this is u cos alpha sin theta. This component will not have any effect because it is just moving in line, as I already explained in the previous example. So only this component will have the effect. So I have already written it here, everything. H I have calculated u square sin square alpha by 2g. R is u square sin 2 alpha by g. This distance is r by 2 square plus h square. Now what is omega? I will consider only this component, u cos alpha sin theta. So this is theta, this is u cos alpha, so this will be u cos alpha sin theta because this is theta. This much I think you can handle. Now u cos alpha sin theta by root over of r by 2 square plus h square, and you can put the values here. In the exam they will be giving you the values and you can easily solve by this concept. Now the next question, find the angular velocity of the projectile with respect to the point of projection when the projectile is about to strike the ground. See, this is the projectile, I can say. This is the projectile, and about the point of projection, see, before it is striking the ground, its velocity is u and its angular projection is alpha. Now just see here properly. If I join a line like this and this is u, so this is what I can say, this is u cos alpha and this is u sin alpha. This u cos alpha, this one is in line with this the point of projection, so this will not contribute in the change in angular velocity, angular displacement. So angular velocity, it will not contribute to the angular velocity. Only u sin alpha will contribute to the angular velocity. So u sin alpha, so into this distance, that is r is the range, and r is u square sin 2 alpha by g. So that is very simple. Now let's understand what is accelerated circular motion. Suppose I have a circle. Just understand this very clearly, because this seems that it is only a formula based topic, but this is not. There is something that is a bit conceptual here. First of all, this particle, now I am talking about velocity, not speed. This particle has a velocity v. This is a velocity. In the very next moment, this particle will have velocity v. Suppose this is uniform circular motion. What is this? Uniform. This is uniform circular motion. Now if this is uniform circular motion, just tell me one thing. This speed, I repeat, I am talking about speed, not velocity. Speed will be constant. If speed is constant, then this v is constant in magnitude, but see, its direction is changing. With respect to this, it is making an angle theta. So what is making its direction change? There should be something. See, this is theta, this is v. So something will be there that is making its direction change. This will make the dv vector. This is v1 vector. This is dv vector. This is v2 vector. Something should be there that is pulling it inside. That force we are going to find. See, so we can understand one thing. Circular motion is an accelerated motion because the direction of velocity is changing. Therefore, we conclude that even if it is uniform, the speed is not changing, the motion is accelerated. Now, what is angular acceleration? Let's see. Suppose we have a circle like this, and a particle is moving like this from, say, point A to B. This is r. Now this, when it was at A, it was at omega 1, and now it is at B, it is at omega 2. Now I can say this rate of omega 2 minus omega 1, that is del omega. My mistake, correction, this is del omega, d omega by dt. This is d omega by dt. This is del omega by the time taken is del t. This is the average angular acceleration. This is the average angular acceleration. The rate of change of angular speed, that is angular acceleration, angular velocity. The angular velocity is changing, it is moving slow, now it is becoming fast. Now this rate of change of angle, that is also changing slowly, now it is becoming fast. So that is the thing. So alpha is equal to del omega by del d omega by dt, that is instantaneous angular acceleration. The concept is similar to the concept of linear velocity. Now let's see in vector form. In vector form, v vector is equal to omega cross r. Now we are differentiating it. See, v vector will be dv vector by dt. While differentiating vector in cross form, you have to be very careful. You cannot change the sequence. First omega will come, then r will come. See, d omega by dt cross r. First omega, then r. Then omega cross dr by dt in vectors. First omega, then r. I am not writing dr by dt cross omega. First omega will come, then r will come, and then you do other things, like you are differentiating it. One, differentiate one other constant and differentiate other one, and this is constant, but don't change the sequence. D omega t by dt, that is alpha cross r, and omega cross v. See, dr by dt was v. V vector is, what is v vector? V vector is definitely the differentiation of position vector. This is very simple, already covered in kinematics. Now let's see this omega alpha cross r, this one, this alpha cross r, this is the tangential acceleration. I will tell you why. This omega cross v, this is the centripetal acceleration. Let's see why alpha cross r is the tangential acceleration. This is our circle, or to say path of, say this is the part of a circle. This is the center. I am not drawing the full, this is being cut. Now a particle is moving with a velocity v. This is theta. Now it is changing, its velocity is becoming v plus del v. So I can say the velocity is increasing. Since the velocity is increasing, the theta is also increasing. Now see, I am just talking about the speed. I can say v is equal to r omega. R cross omega I know, but this v and this r, these are perpendicular, and omega also. So v is equal to r omega. Omega is, I have already discussed, omega is, say, in the this direction. This dot means above the plane of the paper. This is the dot. Okay, it is above the plane of the paper. Now v is r omega. Now if I differentiate it, dv by dt, I am talking about scalar. See, r is constant, r d omega by dt, I can say acceleration is r into alpha. That means the rate of change of the linear velocity, that will be r times the rate of change of the angular velocity. The linear velocity is changing like this. Now the angular velocity, what is happening to the angular velocity? See here it was omega, and here it will be omega plus omega plus d omega. So a is equal to linear velocity is equal to r into alpha, that is angular velocity. See, now linear velocity is changing. Now what I can say here is that, let's draw the curved path. There are two accelerations. One acceleration that is responsible for the change in velocity. It was v, now it is v plus dv. So this acceleration I will term as tangential acceleration. This acceleration is responsible for the change in velocity. There is other acceleration which is responsible for the change in direction. I already told you, even if the motion is uniform, that is, there is no change in speed. This tangential acceleration is actually, it is responsible for changing the speed, that is the magnitude of velocity, that is the del v by del v. It is responsible for that. But there is another acceleration, even if the magnitude of speed is constant, it will change the direction of velocity, like in the very next moment the direction will be like this. So there is something that is pulling it inside. So that component that I am telling, that is centripetal acceleration, AC. So I can write net acceleration A vector will be AC AT, that is tangential acceleration, plus centripetal acceleration. For uniform circular motion, AT will be equal to 0. Tangential will be 0. That means it is moving in with constant speed. But remember, velocity is not constant since direction is changing. Okay. So alpha into r into omega cross v. This omega cross v, I can say it is centripetal acceleration. Centripetal means towards the center. It is constantly pulling towards the center. Now see, a cross r I have already said, that is tangential acceleration. R is the position vector, alpha cross r, and omega cross v, that is centripetal acceleration. Now see here, this is a bit advanced. You may not understand at this level, but if you are a class 12 student, or if you have learned about vector cross product, triple cross product, you would know. Omega cross v, that is omega cross r, v is omega cross r. See, back cap rule, this is called, I am writing here, this is called actually back cap rule. Now back cap rule is, if you are a class 11 student, if you are not able to understand what I am doing, then you may skip this page. You may start from here directly. Okay, you just understand this last, you don't need to understand this, just understand the last part. See, back cap rule means A cross B cross C will be B means this one, into A cross C, A dot C minus C R into A dot B. See, omega dot R, that is omega is lying on a plane which is perpendicular to that of R. So omega dot R will be 0 because of 90-degree angle between them. Omega dot omega is mod omega square, that is into R, and there is a minus. See, if I show one thing, that what AC came out to be, omega square R vector minus. Now what I will do here, I will draw a circle. This is the center. It is going like this. This is my R vector. R vector is pointing outwards. So but our AC will act inwards because it is minus R vector into, it was omega square also in magnitude. So it is centripetal acceleration and it acts inside. So I think this much explanation is clear. Magnitude wise, AC is omega square R, that is V squared by R, because omega is V by R, so V squared by R. Now very important discussion. Alpha again I have to write here, this is d omega by dt, that is d square, that is double derivative of d theta by dt. See, the net acceleration, that is this one, this one, that is the net acceleration, that is the resultant of AT and AC. That I can say, I can draw it also here. This is my circular motion. This is my circular motion. This is AT. Towards the center will act AC. That is omega square r, that I have already shown. And the resultant, if I can draw for both, that will be A. Now see, A net, that is this A net. This will be dv vector by dt whole mod. That means the total, after finding dv by dt vector, I will find the mod. That will give me A net. But if I find just A tangential, that I have to at first find mod, then I will differentiate d of mod v vector by dt. This is a very important distinction, and I will be explaining this in the next video why it is coming so. For now, just understand that this AT, tangential acceleration, that is responsible for the change in speed. It is not responsible for the change in direction, but this vector that has both direction and speed. So I can say that this A net will be responsible for changing both, because it has two components. For changing direction, this AC, and this for changing speed, that is AT, and both resultant will give me A net. So that's all for today's video, and if you like our content, then please subscribe to our channel and share our video. Thank you.